it all starts with the grassroots level where we are not taught to be curious.
Our education system does miss out on that a lot. It's like
Pado
exam do.
Correct. A lot of people don't know that there is much more to engineering than what they think it is, given the kind of exposure that they would have got in their experience. And I thought that the first language that she should learn is something that her dad made. That's my inspiration.
Wow.
Like that's my motivation to build that language. That I focused more on how my language should be written, that it becomes easier for a kid to understand. One thing I'm really excited about is augmented reality, Code Whisperer, or let's say ChatGPT and all. So these are what I feel will be an aid to a developer or an engineer to basically get subjective answers. You may not rely on the entire correctness of it because you don't know what the model has been trained on. I went for an appraisal, Feb or March it was. I went for an appraisal, but my manager said, "Hey Arpit, congratulations, you are getting promoted." I'm like, oh, didn't expect at all. And it was literally that moment when you say that जो है वो ज़मीन खिसक गई पैर के नीचे से, and I actually felt that, and I still get goosebumps when I think about it. Putting yourself in uncomfortable position is really important so that you know what you don't know.
Yeah.
And which is where a lot of engineers think that they are done. And the most interesting part, whenever there is a conflict, I have to be the punching bag. Like basically, if anything goes down, I have to sort it out. If anything goes bad, if two people had a fight, two people having conflicts, you have to be the referee and sort those things out. So yeah, those were the fun times that I had there. Like every leader, I believe, is a grease in the machine, right? They have to ensure that the machine is functioning well. Engineers are the one who are building things. Right. Leaders are the one who are oil and the greases of the machine, right? And the entire machine is the organization and the business. I never thought, when I was starting this course, I never thought about this, that okay, these are my target audience. For me, it was anyone who wants to become a better engineer, right? And a lot of people have this gap on they don't know what they don't know, right? So first problem that I solve with my course is where I cover a massive spectrum.
Hi, I'm Arnav and welcome to yet another episode of SCALER Pod. And today we have with us Arpit, who also is famous as #Asli Engineering on a lot of social channels. Thank you for coming.
Yeah, thanks for having me.
Yeah. So Arpit has also recently joined Google. So my initial question that I start with every episode is, what does your day look like? I probably asked the question twice now. So you were director of engineering at Unacademy, and I think there you were leading a team and managed SRE and all of that. So what was your usual day like there? And after that, I will ask about Google as well.
Sure. Hitting the two butts. Okay. So at Unacademy, I'll talk about my recent part where I was leading. So I was first leading SRE, then I started leading data engineering. So basically, given that I was leading two teams, the day was pretty interesting. Two stand-ups because I was directly managing a team. A bunch of amazing people to work with. Lot of problems. Kabhi like at sometimes some or the other thing breaks in production, developer productivity takes a hit and whatnot. Yeah. Lots of meetings. We can't live without that. Being a director, you have to do that. A bunch of technical discussions, and they typically ended at 5:30. But even post that, we had sometime few meetings here and there. So as a director, it was mostly around technical discussions, a bunch of them. We were re-architecting data lake, or rather rebuilding data lake at that point of time. So a lot of effort went into devising what needs to be done, because when you are rebuilding something, you have to do it the right way. So at that time, a bunch of technical discussions. I felt like an engineer again, which is what made me switch to Google. So like, okay, let me do the grunt work now. So yeah, that was there. And the most interesting part, whenever there is a conflict, I have to be the punching bag. Like basically, if anything goes down, I have to sort it out. If anything goes bad, if two people had a fight, two people having conflicts, you have to be the referee and sort those things out. So yeah, those were the fun times that I had there.
Right. And now at Google, what are you up to? I have, I think I'll ask more about DiceDB and everything, but then you're getting to work on very similar things. So how is it looking like here?
Google, I've very recently joined. It has been 2.5 weeks. So right now I'm still ramping up, but the best part working at Google is basically getting to talk to some of the brilliant people. Like I've recently, one very interesting thing happened. I read a research paper 6 months back. Like I have a habit of reading research papers. 6 months back, I read a paper and I loved it. And I met someone at Google who was author of that paper. I thought I saw the name in the meeting. I was like, is he the same guy? I Googled and he was indeed. And I was so happy. Like, okay, I'm really working with a subject matter expert here. So yeah, that's fun. So right now at Google, it's more about me working, like me trying to understand their entire ecosystem about how they build, how they ship. But more importantly, exploring a bunch of research topics around how we can improve and make Spark faster.
Apache Spark.
Apache Spark faster, yeah.
Awesome. I mean, that's like stuff of the dreams because everybody's just using Apache Spark and going to optimize, but then at that
Very
scale,
scared, but it's fun.
Yeah. So I'll probably try to walk through the last few years, probably like like right from I would say college days to here. How has the journey been? Like, what are the things that you have worked on, and what have been the learnings so far?
So I graduated in 2012. I worked in a not so known company for 1 year. Then I applied. So my then girlfriend, now wife, used to work at basically Dell EMC. So I applied there, hoping ki, if I get selected, we both will work together and get married and live happily ever after. So I applied, and my resume was also not getting selected at that time. I'm like, basically what have I done wrong over here? I realized that I needed a brand, plus I have this passion of exploring tech. So I appeared GATE, did my masters. 2015 is effectively when my career started, because everything before that is like almost zero now. So 2015 I joined Disha. 2 months got bored because I was writing web scrapers there. Then moved to Practo in SRE/DevOps/platform. No idea.
Right.
Very, very challenging work. But one thing that I always, one thing that I was always told to work with is extreme ownership. So what happened there is I showed extreme ownership, and in 6 months I got promoted. Had no idea like why. Like I went for an appraisal, Feb or March it was. I went for an appraisal, but my manager said, "Hey, Arpit, congratulations, you are getting promoted." I'm like, oh, didn't expect at all. And it was literally that moment when you say that जो है वो ज़मीन खिसक गई पैर के नीचे से, and I actually felt that, and I still get goosebumps when I think about it. So then moved to Amazon, Unacademy, Prep, and so on and so forth. So the best part at my career, if I would want to lay out, is I always approach, like whenever I made a switch within an org or outside the org, if I make switch across the org also, I picked out a domain that I've never worked with, and I just like to put myself in uncomfortable situations. Right. So I always think that I have a tendency to overcompensate on the flaws that I have.
Right.
I was very underconfident person. Then I put myself into a position where I have to go and speak out. I was basically, whenever I don't know any domain, I just go and apply for the job for that role, and I use my raw problem solving skills to understand. Like I just apply the first principles to solve any problem that I'm thrown at. So that has been my journey from college to basically where I am today.
Now that's I think really interesting. Like picking up something that you don't know and challenging. That's definitely like a great way to also keep growing, because when you're comfortable, then you're not growing that. How much of that happened, let's say, when you moved from IC roles to people management roles, right? Because that would have, I believe, also have been something new and challenging.
Very new. God. now I'm actually suddenly starting to recall what all happened, and it was June. It was actually May 2020. Unacademy had a data breach. I and few other folks, we rotated entire infrastructure, and that's where people saw that, hey, I know a bunch of stuff around it. So at that point of time, the new VP joined organization, and he saw the work that I did, and he said, Arpit, we need to build an SRE team. Let's build one. I'm like, oh, sir, I'm a principal engineer. I don't know how to manage people. But he said that, yeah, I have some confidence in you. Like, I have faith that you would be able to pull that off. So I said, okay, let me try that. And I was really very scared because I have not directly been managed by a lot of people, because I've been given a lot of autonomy in the job that I've done. really fortunate to have such an experience. But that was also a part where I lacked, that I didn't know how to manage people. And what happened is I had one of my peer working with me. I said, "Theek hai, I'll be the reporting manager of that guy." And he had zero experience with SRE. No one had an experience with SRE. And I pulled him in. I said, "We are building an SRE team. Would you be interested?" He said, "Yeah, I'll be like, I want to work with you. Whatever you say, we'll do it together." I'm like, "Okay, chalo, let's build SRE team." So, and then we got a couple of freshers. And now what I had, like this person had 1 year of work ex, and I had 2 very fresh grad coming in. So 3 people, and I'm manager. We have no idea. So, but because again, me throwing myself into uncomfortable situations at Tracto, I was part of DevOps/platform team.
Right.
And that helped me set up SRE at Unacademy.
Right.
And that gave me confidence that tech part is what I know. I have to work on people part. Fine. So again, applying the first principle, I didn't read a bunch of books there. I just understood psychology really well, that if I was an engineer, what would I expect out of my manager?
Right.
What would organization expect out of me is what I communicated back to my team. Right. So I just followed that part for 2-3 months. Whatever the chaos was there at that point of time, everything settled down. And I learned a bunch of things around that. But one thing that was something that was really new was managing a team is okay. Managing stakeholders.
Yeah.
And that is where I realized that the kind of person I am very vocal about things. I criticize openly. I started to back my criticism with data points. It's something which I never did before. Then I started putting out things alongside data. Why should we do this thing a certain way and not the other way around? So managing stakeholders, had a fight with few of the leaders also. And it was not like basically punching and all, but it was still a fight. But it actually made me a better leader, if I may put it, that now being on the other side of the table. So I was an engineer, being a leader, operated like that, got promoted, became a director. So now when I have switched back to IC at Google, now I really understand what my manager is expecting out of me. So
Exactly.
that gives me an unfair advantage, that because I've been on both the sides of the table, I exactly know what to deliver, how to deliver, what is expectation, how to align myself with organization's goal. Earlier, as an engineer, you just think, okay, I have to do this thing. Like you focus more on output. As a leader, you focus more on outcomes. Right. So this is what I now live by, that whenever I'm picking any work, I prioritize outcome versus output and just ensure that it gets done there. So yeah, that is, and those were the learnings that I had. Like I had to learn a lot of, and more important, I had to unlearn a lot of stuff, because as an engineer, you think, "Arey, manager job is easy, na? Do a bunch of meetings there." but that is where the fun part begins. That it's not as simple as it sounds. It's really complex. You have to manage people who are reporting to you, and you have to manage other managers. Like not directly manage, but talk wisely.
Yeah.
Be data driven. Basically communicate really well. All of those learnings are like immense.
Yeah. Gargly, I think recently I had written the tweet about sideways management, upwards management, downwards management.
Yeah.
The whole thing. I would like to probably like just double click on that once and get to know your experiences on. So, for example, when I was at Zomato, and one of the things that I found was that I was leading the platform team for a while, the mobile platform team, and then also later on the mobile team as such in general, where the app that everybody's using, the consumer app that everybody's using, working on that. So what happens is, particularly let's say in platform, the what the stakeholders expect from you are very different, and then what you can deliver to the stakeholders are at a very different timeline also, and a very different kind of outcomes versus product outcomes. At least the people working in the team, engineers, for them it's also easier to show them the outcome as well. Like, you can tell somebody that, hey, this product manager is going to give you this feature, you're working on it, feature is done, outcome is done, the whole cycle probably 1 month kind of a thing, right? Versus platform, like, okay, if you want to do reduce the size of the app, the effort itself takes a lot of time. And then the outcome, when it shows up, okay, people are uninstalling the app less than 6 months, 1 year down the line and all of that. But then both of them have their own impacts, but driving those impacts and making the case for that impact is probably very different. So I'd like to know like what was your experience in terms of like SRE, DevOps, infra when you're working on that. What are the expectations between stakeholders? What are the things to deliver? How is it different from, let's say, products?
So with that, like no one would support a leader who is not basically giving them anything back in return. So it should be a win-win situation. You just can't say, no, I want to re-architect rather basically, let me take an extreme example. I would not just say, let's move out of AWS and let's say use GCP for that matter. Like they should feel like, okay, it's their win also.
Right.
So whatever tool we are building, whatever efforts we, or rather basically whatever help we need from other stakeholders, right? They should feel like they are part of the win too, right? And that is really important to make them understand. And this is exactly what leaders have to, like when leaders say like we need an alignment from the other stakeholder, this is exactly what they are trying to do. That you don't have to, like you should be pitching the things that you would want to achieve. If you need someone else's help them understand what gains would they get, what gains would organizations get. So the way I basically follow three-step model over here. First, what are the wins for my team? Because my team needs to be motivated to deliver.
Correct.
Second, what are the goals and aims for my organization? Like why organization needs it, right? Once we know why organization needs it, it's easy to align everyone else on that path.
Right.
And third, and the most important part, if I need a cross-team collaboration, I would have to jot down points that would help other leaders understand.
Right.
Why should we help you in achieving this? And it could be a simple one-pager with just 3 points that you are jotting down. But it's extremely important to get an alignment, get things done, because at the end, you have to be the grease in the machine. Like every leader, I believe, is a grease in the machine, right? They have to ensure that the machine is functioning well. Engineers are the one who are building things. Right. Leaders are the one who are oil and the greases of the machine, right? And the entire machine is the organization and the business, right? So I just try to be as much oily, if I may put it, or as much greasy as I can, so that I drive maximum outcomes for my organization. And one of the best way to do it is quantify everything. So I used to have this basically very nagging habit of quantifying everything. People used to get, why are you using so many numbers? Like why is everything so quantified when it comes from you? Like because that makes it easier for an alignment, because they see, if this guy has put in this much of effort into thinking it through, must be correct. I'm not sure if it is or not, but yeah, in most of the cases it was. So fortunate for that. But that's how it works. So I just get an alignment through this 3-step thing. So because in case, and there has been obviously cases where other leaders, they say, no, I don't have bandwidth, or my team doesn't have bandwidth. That's where organization level impact comes in. Right. And you can just go to the manager and say, we are driving this would be the impact on the organization. And anyway, some decisions, like some top leaders do have that veto power on, like, this needs to be prioritized over that. Right. And I can go via that route if needed. But fortunately, I didn't require that. One odd instance here and there. But that's how it would work.
Right. Another question that I'd like to ask also about, let's say, when you were running a more platform-like team where you're building infra for the other people to build on top of, right? I think one is I would probably ask you just a little later, like how do you probably find people who are actually suitable to this, but probably from more of a engineer's perspective, right? What I've generally seen is the idea a lot of people's mind is like, I'm working on product features and all. The next level for me is to work on platform. Yeah. Which I don't believe that's true, right? Okay. I mean, in reality, I don't believe that to be true. It's like both have their own, and you need expertise, like very high level expertise for both the things if you're doing at the top echelon on either. But nevertheless, a lot of people actually want to know, and I hear from lots of times that I'm working on churning out product features a lot. I want to eventually either work on DevOps or on infra or on platforms, right? But I don't know like what kind of mindset shift I need to do, what kind of things I should learn. That has been a question, and I'm sure you also are teaching, so that might have been a question that people have asked. So any thoughts on that?
So unfortunately, there is this sort of separation where people see that, hey, I work in a feature factory where we are basically constantly churning out features for our users versus someone working in the platform team. Now, if I talk about how the mindset shift should happen, when you work on the product, the overall correctness of the product is much more important. Right? For example, you would want to give the best experience to your users because your customers are your users, are your end users. So when you're churning out features for them, you have to keep that in mind that it is complete, it is correct, it is performant, it is efficient. And that has its own set of challenges to sort that out. But when you work in a platform team, which is literally interfacing with all internal teams, it's okay to make mistakes. But now this sort of cushioning that you get, that it is okay to make some mistakes, it comes at its own cost, where you should know a bunch of hacks. Because if you are okay to make some mistakes, but that those mistakes needs to be rectifiable.
Right.
Like for example, if I'm building a data platform, I just cannot make, like, I can afford to make my jobs go down for some time so that the overall data processing pipelines are stopped due to some reason, but it would not mean an end to the world for my business.
Right, because it's internal teams are using
It's internal teams. So when that happens, is you are having this cushion of if something goes down, it's okay, but it comes with its own set. Like, you need to know the fastest way to get those things up. Right? On the customer side, if I talk about product, in most of the cases, you would have already built platforms, or you would be using some B2B platforms to power that. For example, if you're using Kubernetes, it basically takes care of most of the part. If you're using, let's say, Akamai as a CDN or something around that, it does most of the heavy lifting for you, right? So you have to focus more on the correctness and the efficiency part.
Right.
On the platform side, with a bit of mistakes that you can make, you just have to ensure that, like, you get things up as fast as possible, and you would be taking up a lot of work because your focus is not delivering very solid value like in a very short time. So because time is limited, you have to churn out a lot of things on that part, on specifically on the platform side of things. But one thing that really helped me, and I always told this to my reportees, is build a hack. You don't need a perfect solution on day zero.
Right.
You need to have a working solution, because it is okay for us to make mistakes. It is okay to ship subpar things for internal team, right? Eventually, it should become the best in the business,
Right.
And which is what I live by. That getting things in, because the biggest challenge of a platform team is that if platform team slows down, it slows down the velocity of entire organization.
Correct.
For example, if you have an internal tool and that is down, then it's all gone, right? Because people who are relying on that are done. Like, they can't work. For example, if I'm owning CI/CD pipelines,
Right.
and if, let's say, my Jenkins server is down, then every other developer is getting impacted.
Everybody's deployment is stopped.
Yeah. So depending on what kind of platform an engineer is working on, he or she needs to understand the kind of things that their service is supposed to guarantee.
Right.
At the end, the overarching theme remains the same, that a manager is a grease. Similarly, a platform team is also a grease in the machine. They have to ensure that organization is not stopping because of their mistake, but it is still okay. So having that cushion is great, but ensuring that everything moves forward is the ultimate goal there.
Right.
So CI/CD specifically as an example for that. And when it comes to mindset, one more thing on that part, that you need to apply first principles almost everywhere, because today you might be working on Kubernetes, tomorrow you would be working on Apache Spark, the day after that you might be working on, let's say, configuring CDN.
Yeah.
You are not subject matter expert in anything. So you would have to learn on the go. So you have to be a very sharp learner in that. And obviously a lot of things comes with experience. And over time you become subject matter expert on that. So if an engineer is just starting out, or let's say 3 years, 4 years down the line, he or she would want to go into platform, one thing that they definitely have to think about is, how can I become someone who can learn very quickly? Because you would be working on plethora of tools, plethora of technologies in one shot. And on the product side, it's very specific. Like, hey, I'm working on front end. I'll build the best component out there, most performant. Whenever my screen paginates, it would not blow it up, the RAM usage and whatnot. So there you get this very specialized skills. On the platform side, when you're just starting, and I'm saying it in the context of early stage startups or even basically mid-sized company, not in FANG sort of stuff, but where you might not need a solid depth, but you need a solid breadth when it comes to platform, because you would be juggling between a lot of things.
Right. I think I can relate a little bit to like the first Scaler Pod episode with Amod when he was talking about that as an engineer in terms of like long-term growth. You have to come down to the first principle so that, I mean, taking an example, exactly what you were saying is, let's say somebody working on a product, if it's, let's say, a front-end product made in React, you need very good understanding of React and you have to be a very good React engineer in that sense. But maybe you have properties made in React, properties made in Angular, properties made using just jQuery and stuff. So if you're on the platform team, you must know that how the build process for all three of them work, because you are responsible for that. So you can't be like just I'm a React person. You have to understand how front end builds are happening across the platform. Right. Then I would probably ask the other side of the question, which I was saying is, when you are like adding people into a team which would work on infra, internal platforms, etc., right? Sometimes you might be picking people from existing teams. I mean, that's how these teams are always started. But eventually you also do hire from the market as well. So both, I think I would say, philosophically and as well as tech skills wise, what are you really looking at when you're trying to build a team like this?
So in order to, like, when I've been building a team, obviously so basically my seed reportees were actually given to me. So that's how the team starts. But obviously as a leader, I should know what are the things that I want to achieve with this team. We just can't go and say, oh, I need 5 people who knows data engineering. I can't just go with that. I need to know what are the things that I would want to achieve in next 6 months /1 year /1.5 years, right? And depending on that, I would want to build the core set of the people that I would want in the team. And this is something that I've seen, like obviously everyone uses this as an excuse where, hey, the market condition is bad or it's hard to hire good developers and whatnot. You don't need to hunt for developers. Like, you focus on if you have planned enough, if you know what you would want to deliver in next 6 months or 1 year, you can hunt for people with relevant skills, right? One person, like for example, if I knew that I was going to use Apache Spark for some reason, right? That I would, and if my seed team that I have, they don't know Apache Spark, but they can apply first principles to just get it up and running. I don't need that, because if I'm building a data platform, I would need that core specialization, right? I need someone who has done it. I want someone who has done it for at least 2 to 3 years, right? So given that, you need a right set of balance of people who think from the first principles and subject matter expert, right? Because specifically when it comes to building data platforms, it's really because the big data ecosystem is so vast. There are so many tools and plethora of libraries and technologies and whatnot, that someone cannot be a pro at multiple things.
Right.
It's extremely difficult. So that is where understanding where you want this team to be positioned at in 6 months, 1 year, depending on that, I have definitely hired. But I do ensure that I have a nice set of balance between first principle thinkers, go-getters, and subject matter expert.
Right.
And the combination of these three makes a team really good. So the way I built SRE, I exactly knew who was playing which part. And whenever I was thrown a problem statement, I exactly knew whom to reach out to. Because at some place I need to know, because at some place I knew the hack that was to be applied in infra. I just asked the person who was a go-getter, ki kar denge, right? But at some place when we were devising an entire new developer productivity platform, I knew whom to reach out to. And you need that nice balance to ensure that your team has the maximum velocity and create a maximum impact.
Right. And then, because we are discussing actually about data platforms, I'll probably take the opportunity also to ask you about a more of a ELI 5 kind of explanation on, because I hear from more junior people who are just starting out in engineering, is that okay? You see you have to build a product, right? Let's say from scratch, make an API, connect it to a database, make an app, you get started, right?
Yeah.
When the scale happens, we all if we are aware about how tech works, we know that, this company has data engineers, they have a data lake. I mean, what is a very ELI 5 explanation for why does this problem statement exist? Like in a big company where you have so many users and all, what is the challenge in data engineering? Why do we need data lakes in the first place? For people who might not, because for a lot of engineers, what happens is you are either at a company which has not reached that stage, or you're a company which has already reached that stage.
Yes.
So when does the stage come that you need to have data platforms, your stakeholders taking data out? Why do you need to build data lakes and all?
Really interesting. I was very fortunate that I've seen that phase. So always the inception of a data platform starts with a problem. Like obviously when a company is just starting out, you don't need microservices, you don't need basically super sophistication, right? So the day when your product starts to ship, so I typically always give this example. Let's say you have just started to build a product and your company is just starting out. So let's say you use MongoDB, right? To build something, you use React as front end, MongoDB as your database, and let's say a Python stack for your backend. You did that. But now what happened is when you have your entire database in MongoDB, maybe 2 or 3 nodes, you have put all the data and it's working just fine. But after a few years, your CEO comes or your engineering leader comes and says, "Hey, I want to see these numbers." You as an engineer, you said, "Okay, yeah, I'll just basically quickly fire a query and ship you those numbers," and you give those numbers to that. But now these folks need these numbers every now and then. So then what do? You put a data visualization tool, let's say a Tableau or something that has a MongoDB connector. So you connect to that. But then what happened is now who will manage that Tableau? So you say, hey, let me if these metrics needs to be reported weekly to the leadership, there has to be people who are doing this sort of analysis, because you can't let your product engineers, like you don't want to waste your product engineers bandwidth into that. Right? So that's where you hire data analyst.
Right.
Now data analysts come into our organization, they say, hey, I don't know MongoDB. Because most of the skill sets of data analysts lie around SQL databases.
Yeah, operating Tableau, operating
Tableau,
and understanding SQL a bit.
Understanding SQL in depth, right? So that is their core skill set. Now they say, "Arey, but your database is MongoDB. I don't know anything about it." So then what do? You copy the data from MongoDB and put into a SQL database. Let's say you start using MySQL, right? Yeah. So that's what the next phase of evolution is. But then your data analyst is happy. He or she is basically churning out metrics for the senior leadership. Everything's basically everything is hunky dory now. But now what happens is your product grows out, it grows big. Now more data analysts join. Now the data pipeline. Now basically this is your first data pipeline that is copying from MongoDB into MySQL.
Somebody's running a cron job,
right?
For it.
Yeah, cron job, normal cron job, right? Obviously, you always start with that.
Yeah.
And you had that. This is your step where now few more data analysts have joined, few more product engineers, few more database. You keep on adding more such data pipelines that is copying data into this. Now, earlier you had MongoDB, now you have another Postgres, or you are using DynamoDB or Elasticsearch, you are putting data into this MySQL DB. And then this MySQL DB, now what is happening is you are having ad hoc pipelines that are continuously taking data from your transactional DB and putting it into this centralized, into this MySQL, which is acting as a data warehouse.
Yeah.
But now every team has to separately manage. That is where you come ki, hey, now why my product engineers are writing this data pipeline for every database that they have. So then you grow and say, hey, now we need a data engineering team who would write this who would own this pipeline, do those data transformation and put the data into this MySQL. Eventually, MySQL falters because kitna scale kar loge? At point MySQL hits its limits because it is not a data warehouse.
OLTP, OLAP, threshold it reaches.
Correct. So then you take this data from MySQL and put it into, let's say, AWS Redshift. That becomes your data warehouse. Or you put it into BigQuery. And now what happened is you put all the data into that. But now who is doing it? Because now you have a dedicated data engineering team. They have migrated the data, they own the pipelines and they move it there. But then, because it's a managed offering, costs start to shoot up. Because AWS Redshift, GCP BigQuery, everything is expensive. Right? But they are super tools, but they are expensive. So as an organization, you would want to chop down on the cost. But now what you would want to do? Okay, now if you want to chop down the cost, the first thing you see, there is a huge amount of data. Can I archive it somewhere? Or how do I reduce my cost? That's where you say, array, BigQuery or AWS Redshift is expensive. Let me move this data into a blob storage like S3, create a Hive sort of, basically put a Presto or a Hive in front of it, use Spark as an execution engine. This is where now you see all the big data terms coming out. Right? And this entire ecosystem of now you being able to seamlessly query between your transactional database. between your BigQuery, between AWS Redshift, between any sort of database that you have, is where this entire platform comes in.
Yeah.
And every company goes through this part, and then the amount of sophistication that you would want to add into devising this data platform, it depends on basically company and the product use case that they have. But basically this is a typical evolution that happens when a data platform is introduced in an organization, and then it reaches to a level of sophistication where no one knows what's happening because infra is abstracted, Spark is abstracted, data warehouse is abstracted. And then to reduce cost, you put all the data into S3 / any kind of blob storage, maybe anything which is HDFS compliant. You dump every data into that, and then you basically simply seamlessly fire query on top of that.
Yeah.
So this is how the entire world like the entire evolution happens of a data platform.
Right.
And then you see all the jargons coming in like Hive and Spark and Apache Hudi and basically Parquet, Arrow, Flink, Flume, and so much more.
Yeah. I have never actually been part of building something like this, but I've seen these transitions myself at least. So I have mostly like front end and client side has always been my expertise. But yeah, I mean, this journey is really important. I feel I've seen engineers who have seen this journey and who have not. Seeing this journey is very important, I see, because you're operating on top of complexity, but without the knowledge of why the complexity exists, then you might not always come up with the best solutions to it. So this, I mean, my recommendation generally is that if anybody can go through this journey anywhere they can get a chance, they should take it, because this makes you a really different class of engineer in that sense.
Because you would know why this solution even exists. Like why Spark even exists, or why do we have to build a data lake? Because most people know, okay, like most engineers would think, hey, I know Spark, I know this. But the engineers who know why have this been even in the first place, that's what makes him or her the special engineer, right? They know that I'm diving deep into stuff. I have the product context, I have the business context. Like why is this data lake important for business? Because at the end our job exists because business exists. Right? You would want to ensure that no matter what happens, business continues to be in function. Like why leadership even wants these metrics right now? Unless you have product context, unless you know why has been such a requirement, like you would not be building a good solution. Right? That makes you a very good engineer.
Right. I will change tack now to actually finally talk about something that everybody would be interested in knowing about, Asli Engineering and the origins also. I think, remember I saw a long time back when you initially started making some of those, doing simple explanation for technical terms on LinkedIn and some of your early videos. So I'd like to ask really right from the origin, like what made you think that you want to, teach, let's say, system design? What inspired you to do that? And then, of course, we'll talk about how the journey was, how things are going and all.
Yeah. So, I have a habit of setting my goals. So I don't call it as New Year resolutions. These are goals that I set. So last week of December, every year, last week of December, I set my goals for the next year. I set 4 goals. I fixed formula, and I've been following this for last 8 years now. So I set 4 goals, one for each quarter. Right? And one of
personal goals.
Yeah. These are all my basically personal goals that I would want to achieve. Like this, like in 2020, I wanted to learn Morse code, which I did. Next year, I want to solve basically Rubik's Cube, like try speed cubing, right? So I have these sort of goals that I set. One is non-tech, 3 are deep tech, like because like obviously engineering, right? So in 2019 December, I sat with one of my direct reportees and I worked with him. I said, let me start a newsletter. For some reason, 2019, people started writing on Substack. I discovered that platform on Hacker News. I said, chalo, I'll write a newsletter, because I used to write articles back then, but I stopped for some reason. I said, and basically this was an opportunity to start. So 2020, on last week of December 2019, obviously, if I said, okay, I'll publish one article every week, that was easy to say than actually write the articles, right?
Absolutely.
So what I did is I sat with him and we wrote 52 topics that I would write articles on. So once I already know the 52 topics, it makes life much simpler, because now I just have to write on that. And I have not really used all of them. I just used 4 out of that, out of those 52. But I still wrote every single weekend or every single Sunday. I published an article on my website and through my newsletter, and that triggered or that sparked the interest into real engineering. So I went deep into research papers, why a certain thing happens a certain way. So 2020, my first goal was to have a weekly newsletter that publishes every Sunday. It would be a deep dive into a core engineering concept. So I dive deep into the formats of an image, MP3 file format. I dive deep into basically gravitational algorithm, approximation algorithms and whatnot. And that made me a better engineer, to be really honest, because most of your day job is typically writing APIs. Here I was diving deep into research papers. Now that I had a very strong foundation in college because I studied a lot. But with this, I got this thing ki while working also, I can explore a lot of other parts. Now that was a moment ki, Arey, I can learn. Like it's like people say that after you work for 2 to 3 years, you are almost like ki, now I cannot learn new things. Right?
Yeah, sometimes happens with people.
Basically, people get very slacky and all ki kya karna hai.
Yeah.
But then this sparked a very nice interest. Ki, yaar, let me do this deep dive, and I built a very solid understanding. And then my second goal for 2021, because I wrote for entire year. My daughter was born in August 2020. And like 6 months tak, I would not want to do anything. For 6 months, I'll just focus on my daughter because she needs attention. And as soon as 6 months end, I would do something. Right? She was born in August, September, October, November, December, January, Feb. Feb 2nd is when I announced my course. So I was waiting for the day. Now 6 months are done. Now I'll do something. Now my resolution for 2021 was to earn 3 lakh rupees out of my job. Right? So basically job salary basically kept apart. I would want to earn 3 lakh rupees on the side because I wanted to buy an iPad, a laptop, but not with my money. Like basically not from my salary.
Yeah.
And I kya kare? So I built, at that time my readership on my newsletter was 3,000. I used to get a lot of good comments on that yeah, it's really deep. Like it takes us 2 weeks to go through that. And I took it as a compliment rather than ki, arey, like that I'm not basically catering to my audience, but that's okay. And that 3 lakh rupees that I wanted to earn is what triggered. Basically, what do I know the best? I've been very fortunate throughout my experience to have built systems.
Right.
6 months getting promoted at Practo was a big deal for me because in 6-7 months of time, I started owning 8 services. I realized that I knew stuff, and which is like, okay, that is done. I didn't know I could teach or not, but at IIIT, when in order to get the GATE scholarship, you have to be a teaching assistant or help some professor out. So I thought, let me become a teaching assistant because I needed that 8,000 rupees of my monthly allowance so that I can spend something on my college. Right? So I wanted that, and and all of my juniors, like what I realized is all of my juniors loved the way they loved the way I taught. I loved helping them out. They were building their own LS, and I used to help them. Being a TA, it was my responsibility. But even for the people whom I was not a TA of, I still helped them on my own time. And I realized that I can teach.
That's a superpower I have.
I realized that hey, I could communicate things really well, and done. Chalo. So then, how do I get my 3 lakh rupees? So that is where on 2nd of Feb, I announced my course on system design. And because that's the only thing that I knew, given given how fortunate I was throughout my career to have built actual systems. And I said, let me start a course. Then I was devising what should I teach? So I first announced the course, and I did not have topics in mind. I just knew the high level fragments that I wanted to cover. For example, databases would be week 2, distributed systems week 3, and I just wanted to cover a massive spectrum. And I said, let's pitch it. And I did not have like the exact granular statement that I want that I was going to cover, but I knew it has to be deep tech. Because otherwise I would get bored, right? I don't want to start what is load balancer. Like I would want to dive deeper into this is how load balancer is designed, right? And really deep into it because I built myself one for fun, right? So that's how it started. So that happened. For my greed of earning 3 lakh to buy an iPad, which I still carry in my bag every single day. my laptop because I didn't have a personal laptop back then, and 1 lakh for taxation, and वो सारा side में करके, right? So basically keeping a third of my income on the side for taxation purpose, I had this goal, and that's how I announced my first batch. I thought who would join. Basically kept it at 25 people, capped at 25 people first batch, and saw ki, basically let's see how it goes. And my threshold was 12 because at 25,000 fee, 12 people equal to 3 lakh. 3 lakh, right?
3 lakh
lakh,
after
right?
taxation, yeah.
So that is what I went for. Ki, chalo, this is what I'll have. And 12 pay, and as soon as the 12th enrollment happened, like done, chalo, course is happening. I got my 3 lakh laptop, iPad, done deal. As soon as I got my 12th enrollment, the first thing I did, went to an iStore, got my iPad. Done. Chalo. Because I have to teach well, right?
Yeah.
So, and iPad was the must for teaching well. So I did that, and that's how the ball started rolling. And while I was devising the curriculum, I thought, yeah, what should I do? Because I had 7 topics that I definitely wanted to cover. What would be the 8th week for? Because I could not, it felt weird if I put my course for 7 weeks. 7 seems weird number. Like 8 is like, chalo, malab, it's like basically complete 2 months time. So what should I put in 8th week? I was thinking, mock interviews, like, no, yeah. This should not be an interview. Basically, this should not be a course focused on interview. So, because on 2020, I wrote 52 essays every weekend. I dived deep into research papers. I realized there were some fantastic algorithms that real system actually uses. I thought, let me create algorithmic system design, where I talk about the actual algorithms that made those systems possible. Like for example, New Relic, Datadog. These are famous tools who does metric ingestion at scale.
Yeah.
Right? But are they storing raw data as is? If they would, then their storage goes berserk.
Yeah, they can't.
Right? So is the answer to this a simple compression algorithm? Definitely not. So then what are they doing something special? So that's how I started diving deep, because I went into approximated algorithms part really deep, like literally understood the math behind it. I was really confident on how they do it. I went through their blogs. I literally read 182, and I'll tell you why I know the number, because I use Hypothesis to tag all of my blogs. 182 blogs during that phase to do research for my system design course. Right? But most of the system, because I built personally and handled it in production, I knew the kind of decisions I took to go with that particular architecture, the kind of challenges that would come in when things go berserk. Like for example, when I'm having a spike of users coming in due to some marketing SMS that has been thrown out. Right? So my real world experience with my deep understanding of advanced topic made it like really nice blend of my course. It basically covers a massive spectrum, and really fortunate ki first 25 people who put trust in me. I'm still thankful to them. I still remember the first enrollment that happened, second, and I was really happy. People are paying, nice. 6th enrollment, and then suddenly no enrollment for 7 days. I'm like, God, I'll not meet the threshold. Then I put a promotion post on LinkedIn. Hey, I'm doing this. These are the people who are joining. And then it started rolling out. So yeah, that's how it has. Then basically that's how my course started. In March 21 is when I took my first batch. And since then, back-to-back courses, one every 2 months, 8 weeks, no weekend breaks, nothing. Going all in on that.
Right. And then I'd like to ask you about the most interesting things about you. For me personally, have been Revine and DiceDB, right? And so I remember like there are a lot of times people make these Python parser based esoteric languages, like I think Arnold and Bhaylang somebody made, and it used to interest me. I've also once tried doing it, and that's the reason also is I just love that you have started working on Revine. So how did that inspiration come, and what was the experience creating your own language?
So Revine is it has a very interesting story, and it's not at all made up. When my daughter was born, 24th August 2020. Obviously, my daughter will be an engineer. I don't care what society says that I'm putting pressure. I don't care. She's going to be an engineer. And I thought that the first language that she should learn is something that her dad made. That's my inspiration.
Wow.
Like that's my motivation to build that language.
Right.
And then what happened is, and actually it was August when she was born. After that 2 months, I got to observe, I have a kid now. how to take care, sleepless nights and all of that. In 5th October is when I got that thing, like I got that idea when she was born. Let me revisit that. So 5th of October is when I laid my first foundation that is this even possible? So I started studying. I saw how basically Whitehead Jr. cracked the code with Scratch. And basically that's how I got to know something like Scratch exists.
Yeah, it's
I
a
learned
very nice thing.
Yeah, it's very nice thing.
And there are a bunch of other things like that on code.org as well. Google has also made one similarly like that.
Everyone
Blockly,
is going to
Blockly or something.
Blockly is the name of that. So what happened is with Revine, like what I realized I learned programming when I was in 5th standard, and I learned Logo, right?
Yes.
So where you move that basically turtle, right? I learned that, and what I realized is like coding in that language, because I was writing, it was really helpful for me because I had to use my brain to visualize it.
Procedural thinking,
if I'm yeah, correct. So I wanted that, and Scratch did not have it. Right?
Yeah.
And I did not want my daughter to learn that very basic looking, ugly, black background, white turtle going here and there. So I said, can I create something that sits in between? I don't want it to be very drag and drop like Scratch. I don't want it to be extremely textual like Logo. I want it to sit right in between, but as a very good introductory programming language for kids. So I had my goals in mind that I wanted to build a language that is text-based, but still you can do animation on top of it. So think of it like Scratch with a bunch of code that you can write. Okay? So that's how this idea was laid on 5th of October. 6th of October is when I wrote my first line of code for that to just quickly test my prototype that is it even possible or not. So 6th and 7th I wrote that prototype that this is something which is possible. And I was like really happy that my Hello World worked and I could build a text parser with... I forgot the library that I used for that. I wrote a very simple language, which could then translate into a JavaScript code and execute in browser. Right. So obviously that's exactly what a compiler is. Right. You take a bunch of text, you basically send it through some compiler which spits out either machine code if you're doing backend programming, or it spits out a JavaScript code if you're doing front end. So my job was to write that layer in between, and I quickly wrote a prototype in 2 days. Saw it's working, I'm like, chalo, this is the foundation of my language. And since then, I've started evolving into it, and then I set my goal, which I'm not meeting. This 31st December, I have a deadline that I have to create Chrome Dinosaur game in that. Hopefully, this pushes me to complete it in next 1 week. I'll do that because I'm so close to that. It's just that I'm got distracted with DiceDB and job and all. But that's how it started. And then again, first principle thinking all around. Right? Instead of thinking, oh my God, I'm going to build a language, I have to build a massive compiler and I have to write my own parser. No, there are libraries who do that. And then more importantly, just get those minute details right? That I focused more on how my language should be written, that it becomes easier for a kid to understand. So I put myself in my daughter's shoe, that when she would be 5 years or 6 years old or maybe 7 years old, that how I want her to learn a programming language. Right? And I put myself in her shoe that what she would be most attracted to. And then I said, ki, chalo, let's build it this way. So, but then my syntax was very, very bad. What I did is I applied for Sequoia search. Let me create a business out of it, because that's what the natural thing comes now. Arey, I'm building my own programming language. I'm basically competing with Scratch. So let me build a business out of it. And I applied to Sequoia search, but now, why I'm telling this? Because when I was applying, the kind of questions Surge asked, that helped me shape my product.
Right.
Product in this case, right? So I said, like, why should I create my own syntax? I spoke with basically Mr. Krishna Kiran. He was head of engineering at Amazon Pay, and he told a very interesting thing. So he has basically nothing to do with Sequoia. I was just asking him. Asking him for his feedback on my language.
Right.
He suggested a very interesting thing. He said that, Arpit, why are you creating your own syntax? Why can't you keep it Python-like? Why can't you make it like a kid version of Python? I'm like, that's pretty neat. So then 2 sleepless nights, I refactored my entire parser, redesigned my entire syntax, and now I made it very close to Python.
Right.
Very close to Python. So that was a big refactor that I had to do, ensuring my existing functionalities don't break.
That's a good idea actually, because I have seen people start electronics programming with Arduino.
Yeah.
And the syntax is exactly like C.
Yeah.
So while this is a language called processing
Yes,
that they
yes,
use.
yes, yes. Processing JS.
Yeah. But it's very relatable. Like if you upgrade yourself later to embedded engineering,
Hmm.
that experience carries over.
Yes,
It's not
exactly.
like I was doing something else.
Exactly. And that's what struck me. Like, I should have thought of it, but because I had this very nice feedback, I re-implemented my entire parser. I kept my entire language very close to Python. I exactly know now how, because I'm also very familiar to Python, I exactly knew how my daughter would love to learn a language while giving all the basic functionalities out of the box. Like, for example, to detect collision. In block, you have to drag, drop, and add some random thing. And it's so colorful, it's so vibrant.
Yeah.
It basically pricks my eye. So I don't like that interface at all. So I said, if I don't like it, hopefully my daughter also does like that. Basically, that's my hypothesis that she would not like that either. So I said, let me keep it normal text based with giving all the basic functionality to create micro games in this.
Right.
And that's how it is now converging to that level, that I had to build my own object detection or object collision detection rather, then ensure the function around gravity works, all of that. Like, and for me as an engineer, that was much more exciting. So I digressed twice where I went into the math and the physics behind it. How would I detect collision? Then object boundaries, object overlaps, all of that. I went into understanding how games work. Some I think there's a YouTuber on who puts a bunch of videos on game creation.
Okay.
I watched bunch of them to understand. I didn't understand a thing, but then I started scribbling on my iPad and I got the idea. Acha, this is what I can use over here. So that's how it evolved. New challenge every day where basically whenever I work on that. But it's really fun, and this is the true origin story of Revine. And the way the name Revine came in was because I wanted to use the prefix re, because I could then leverage, because it's again effect of Sequoia search, that re, because I can do relearn, I can do reimagine, like all the things around unlearning starts with re. Reimagine, refurbish, relearn and whatnot, right? So that's why re is what I fixed with, and then I said re se kya acha lagta hai, to wine dal dete, rewind. So that's how it happened. And now I'll definitely be completing my Chrome Dinosaur game by 31st. Like I have to complete that goal. But out of 4 goals that I set for this year, that is the only one that is remaining.
So collision detection in it is like for the user who would be writing. For them it will be like if collide like
if
that.
this collides this, that's it. Behind the scene math
the compiler
and physics,
will
I'll
do
do that. Yeah.
Nice. And then obviously the next project which I have been starting to look at the code as well as a little bit the DiceDB thing. I saw that you started off with like trying to understand Redis, then rewrite Redis. How did that happen?
It all started with like in my cohort November batch, someone asked, I heard that basically Redis is single threaded. Why is it so fast? Like, I don't know much about it, but I'll definitely come back. So that question was sparked and I really had to come back, but I was stuck in a bunch of other things. In March 2022, someone again asked me that same question. Like, I have to dive deep into this now. So I knew something around IO multiplexing is the key. So I had a bunch of keywords in my mind which I wanted to share. Which I wanted to explore. Then Alex Zhu created a video on why Redis is fast. So that was a trigger point.
That's a very famous video.
So this 3 thing triggered me. Hey, Arpit, now this is the time you should dive deep into Redis source code. So what happened is, I downloaded Redis source code. I saw it's on C. And I was like, array, after 10 or 12 years of work, it's like looking at C code this vast, how would I understand? So this is where in 2020, I explored C Python code base, entire code base. I didn't understand the thing for first 2 weeks, but then I started to hold grasp of it. Those learnings from my 2020 days where I was understanding C Python source code led me to understand Redis source code with ease. So I used like my basic first principle thinking again, Control F, loop. This is literally what I searched for because I wanted to understand how is single threaded Redis so fast, right? And that was my entire idea. I want to find how loop work. Like I've always heard event loop. Like let me go in depth of it. What the hell is an event loop? And obviously, if you search for this, you have a very nice YouTube video by a guy who talks about what event loops actually are in JavaScript. I forgot the name. JSConf video.
The loop.
What the hell is the event loop? That's exactly the
Philip
title.
Roberts, I think.
I don't really remember his name, but a brilliant video, brilliant visualization.
Yeah.
But but that's still very high level, right? Or it goes
it's
there.
more for when you're using the event loop.
Yes, exactly.
You need to understand how it works that much level it. But how you build the event loop, that's not covered.
That's the fun, right? So I wanted to know how it is actually, because when someone asks me in my code and I don't have an answer for that, I feel very bad. So I have to go deeper into that. I did basically Control F loop, and I found 50-60 files matching it. Okay, let me start basically drilling more into it on if I find, and I found a file where the event loop was written. Okay, now it's time to go deeper. So 2 days straight, I just spent a bunch of time understanding, and given that I had strong foundation around assignments that I did in college, I knew something around IO multiplexing. I knew something around basically system calls, how they function, and what actually happens at kernel level. I combined all of them, went through the source code, built an understanding. But now comes the fun part. Theoretical understanding, skimming through the code is okay. But if I explain this to the people who have asked me, why is this so fast? They would ask me another counter question. And if I say, I'll come back again, that's very bad. I want to dive deeper. So I'll implement my own event loop. I'm okay, this is in C. If I implement event loop in C, it would be Control C, because I would be very much tempted to do Control C, Control V.
Yeah.
Right? No, let me write it in Go. So this is what, as I said, I force myself into uncomfortable situations. I forced myself into writing this in Go. So in 20 minutes, I got my prototype working. Event loop, I understood it in and out. Now, if anyone asks me questions about it, I have 100% answer. This is exactly what is happening behind the scenes.
Right.
And that's how that event loop, one single Golang file I wrote about event loop, tested it, worked fine, all good. But now what? What do I do with this? I had the answer that people ask me, should I stop over here? No, then engineer within me kicked, let's do something more with that. So then I started diving deep into Redis's source code to understand how they're actually executing, because that's the next part. Event loop is fine, right?
Yeah.
Having an understanding of event loop is fine.
This is the building block.
Yeah, that's the first step around accepting the commands. Right? That is done. But now, around evaluation, why is it so fast? Why is Redis so fast? Accepting the command on a single thread event loop is understood, but why the execution is so fast? So then I started diving deep into what happens after that. And that's how I understood the overall Redis serialization protocol, how they're using structures, how they're optimizing on every single function. And then I said, okay, I started re-implementing all of that to get deeper understanding. Now what? I've gained so much of understanding on this. Let me create a course out of it. So that's the natural next step.
Yeah.
So then around all of this, so that's when I thought, let me create a really deep, in-depth course on Redis internals. Redis internals, theoretically, a lot of people will tell, right? This is what happens, hyperlog, Bloom filters, and this and that.
Yeah.
What comes when you implement it, right? That's where the devil lies in the detail.
Yeah.
And I loved it. Chalo, let's go deeper into it and let's create a course. So I defined a course structure, and I was always fascinated by, I want to implement transactions, man. I have to do it. Okay, command pipelining, transactions, persistence, these basic set of commands. So I did not focus on advanced data structures, but I focus on get, put, delete that you need, expiration, very fancy algorithm that they have. I re-implemented all of them by understanding it in depth. This is what I want to do. Now, I have course, right, which I did. But now I just cannot sit idle, because this is such a beautiful piece of code that I wrote ever with unit test and all. Okay, let me do something more with that. So then I said, because I spent 2 months understanding the entire Redis source code and re-implementing it, I realized the technical debt that they hold. I realized where they can falter. I realized what it would take for them to implement XYZ, more features on top of it. And can I leverage that? So that's the next step. So that's where now DiceDB's, now I have a roadmap for DiceDB that started as a big inspiration from Redis. And now it will take its own course, right? So it still talks the Redis's dialect. So you can use it as a drop-in replacement. Normal Redis CLI you can use to query DiceDB. Right? I've basically kept it 100% compatible. But now DiceDB will take its own course. That now what next? So the technical debt that Redis holds, I would be solving that. The overall, because given that it is written in C, just to go a bit of detail in that, given that it is using C, It cannot do because and plus it is implemented on top of a single threaded event loop.
Yeah.
Multi-threaded operations are out of the picture for them.
Yeah.
Golang has very efficient concurrency.
Yeah.
Can I make a multi-threaded? So the idea is that I would still need to have a single-threaded event loop because that is what is
IO
making it
multiplexing,
really interesting. But I would need a multi-threaded execution. Redis cannot do that because p-threads are very costly. Obviously, there are libraries to make it faster. But if I use Golang's, the way Golang does concurrency using Go routines is extremely efficient. Can I leverage that? So that's what that is what it would take its own course. So few things that that DiceDB would have that Redis would not. One of them would be semi-persistent storage because Redis, everything is kept in memory. Although it gives persistence, but it still needs to keep all the data in memory.
Yeah.
Problem. Can I have a semi-persistent storage with DiceDB? So that is what we are evaluating. If we can do it, brilliant. Because then we are typically challenging the limit of Redis because no matter what you have, you still need to have enough RAM to put all the data in RAM for Redis. Here, it's disk bound, right? May not we flush all the thing to disk, maybe some data structures to the disk, which are efficient there. Second,
this is also from a world where SSDs were not that common.
Exactly.
So today it's ubiquitous.
14 years back.
14 years back.
Yeah, it was not.
On cloud, SSDs were like 10x the cost of normal disks.
Yes.
Now nobody asks normal disk or SSD. You deploy directly SSDs.
SSD only. So leveraging that comes as a first semi-persistent storage. Second one is what I am thinking on doing is around a multi-threaded. So Redis does not have a command because the way Redis right now evaluates is it gets a command, it does that evaluation of that command, and then only it moves to the next command. What if I add a command because I can opt for a multi-threaded model over here? What if I introduce new set of commands that could leverage all the cores of my machine? Redis, even if you deploy, let's say you need a 32 GB RAM to hold the data in Redis, and let's say AWS gives you a machine that has 8 cores. For 7 cores are doing nothing.
Yeah.
Right. So even if you have those seven amazing cores that are sitting idle, but because you need 32 GB RAM, you have to deploy it. You have to deploy Redis on that instance. So then those 7 cores are sitting idle. Can I leverage that? So then I came up with an in-memory analytics use case that could leverage the other 7 cores that are sitting idle.
Right.
So for example, if I work on a use case that or I introduce some commands or some data structures that could leverage basically parallelism. For example, very simple, search. So Redis has its own search module, which is an external plugin. But what if I have a search that could search across my Dice data that I have in parallel?
Right.
That would make it much more efficient. It's still a single command execution. While Redis is doing it with indexes, what if I parallelize access to that also?
Right.
So that is one more direction that I'm planning to go. So a hybrid model around single-threaded event loop combined with multi-threaded execution.
Right.
So that is another direction I'm going in. So hey, interesting charter, interesting roadmap is what I have with Dice.
You can do a CQRS layer and the commands will go to multiple threads while the queries will go to multiple threads. The command will still be the main thread.
So wo main pe, and each command may leverage, like there would be some commands that are that are designed to leverage multiple cores. While there are some commands like get and set which does not need that, but they would sit at one place. Another thing is shared nothing architecture is what I'm exploring. And one very interesting thing that I would want to do with is most databases are close to data. They're close to raw data structures. Like Redis offers you data structures. They don't offer you product use cases.
Right.
So for example, most common thing that people search for Redis is how can I build leaderboard on Redis? Right? That's the most common use case. Why is Redis? So then you have to use zadd, which is a sorted set in Redis to do that. Why can't Redis just expose a leaderboard set of commands to build leaderboard use cases?
Right.
So databases, if you see the current shift that is happening in the world of databases, it's shifting more and more towards the side of application with basically Firebase, a classic example for that, which is keeping it very close to application. Now, Firebase is still a raw database, right? What if DiceDB exposes commands that are application specific or that are product specific. Let's say I have a command for leaderboard. No one really needs to care what data structure should I use. I'll just use leaderboard as my command. Leaderboard space put space key space rank. Done.
Yeah.
Right? Behind the scenes, so it looks like an abstraction that behind the scene I would be using a sorted set to implement it.
Of course.
But it makes it much simpler for user to not know the internal, that I have to use sorted, because otherwise most people get stuck at this, that which data structure should I use?
Yeah.
And sometimes it is also intimidating. So can I make my database go closer to the product use case rather than the data structure use case? It's a far-fetched idea, but this is what I'm thinking.
Nice. Interesting. I'll ask a little bit more about the sort of, I would say, experience in the classroom with your programs as well. Especially like what do you really focus on? Because I see most of the people I've talked to, some of the people who have done the program as well, like they're good engineers already. They're thinking, okay, what is the next thing to learn? Right. And while, I mean, we discussed when we had met at that conference as well, that, understanding systems also important, but still when you're building things, being close to, simpler things, understanding the cost of what you're building, many of these things are very important. Right. So how do you go about generally in the program teaching people? Because for them, a lot of things could be also very theoretical and very distant from them, because maybe what you're teaching exactly that component, they've never used that.
Yes.
Right. But obviously, you're learning that in future, someday I build a more complex system. These are the things that I will need. So what is like the general philosophy with the program as well? Like, what are you, I would say, even trying to achieve with teaching these people? What would you want to see them become also in that sense?
So one thing that I've been like, I never thought when I was starting this course, I never thought about this, that, okay, these are my target audience. For me, it was anyone who want to become a better engineer, right? And a lot of people have this gap on, they don't know what they don't know, right? So first problem that I solve with my course is where I cover a massive spectrum, that most people don't know about connection pooling. Most people don't know, or rather, a lot of people don't know about connection pooling. A lot of people don't know about those micro CDN optimizations where you can literally optimize images on CDN. They think of writing their own image optimization service. Oh, why? CDN gives you, which you just pass necessary query parameters and build that, right? You don't have to build everything on your own. So which is what is a major gap which I saw on the understanding of the overall understanding that people had in this domain. So that is one that I do, that I build, like I empower them or I enable them to build systems the way they're built in real world. Again, I've been very fortunate that I have got to work on such systems with very strict constraints around cost, that infra cost should not bloat up. So my entire mindset is all structured around how do I make it as fast as possible with being as cost effective as possible, right? And that is exactly what an engineer needs to become a better engineer. So this is what I focus on. First, make them explore a massive breadth of systems, because a good engineer is typically good in a certain area, might be unaware of other areas, right? And why explore? Like, it's not just you should know. It's more about leveraging cross-pollination. Like, for example, if I would have never worked on a platform team at Practo, it would not be possible for me to establish an SRE team at Unacademy. Right? Because of my past experience, I got to do this.
Right.
Because I worked on a system that cold tiered the data, I could easily, right now I'm working in a team that works with big data ecosystem. If I would not have done that, I would not know this. So there is a cross-pollination that is happening across domains, across the jobs that you do. So I want them to experience that. So with my program, what I focus on more is, like, these are all great engineers. I want to elevate them. So a lot of people get stuck, hey, what do staff engineers do, right? They just sit and think. No, that's not true. So they have these questions like, how do I go to the next level? Because a lot of people feel stagnated at a point. And what makes them go to the next level? It's ability to design a system that is typically what they have not seen before, which is ambiguous.
Yes.
Right? So that is where what I typically focus on is a lot of brainstorming. Because of a lot of brainstorming that we are focusing on, is they build this muscle memory. Like it's literally It literally gets ingrained in their brain. This is how I should be thinking of, beat any system that comes to, like beat any system that is thrown at me. I'd be able to understand it. And again, it goes all through by first principles.
Yeah, breaking the whys till
Kaise karna
you are
hai,
the simple questions. That's
one thing that I always say in this is an engineer or a good engineer wears 3 hats, right? Hat of a product manager. Very counterintuitive, but you have to wear the hat of a product manager and think that who is the consumer of the thing that you're building? Maybe an API, maybe UI, maybe design, anything. So wear a hat of a product manager. Second, wear a hat of an engineer who is going deep into implementation detail. Otherwise, your system would just be building blocks. You don't know the nitty-gritties of it, because when you dive deep into the devils of implementation, you realize that, I have to apply connection pooling. Otherwise, my database would choke off. Right? And third is wearing a hat of an architect. When it's about wearing a hat of an architect, is about how do you make system extensible enough in order to accommodate other use cases. Now, this really comes from when you have experienced it firsthand. And to be honest, not a lot of people are really fortunate enough to have a wide range of experience. So I just try
once
to
in life
fill
if
in
you
those gaps.
hit the tech debt wall,
Yeah.
then that comes.
Yeah. So I just try to fill in those gaps into it and help them understand how we are approaching this. So I never say ki, I always put an emphasis on this, that we are not building so like I never utter the term interview throughout. Like whenever someone asks me a question, ki, hey, in interview someone asked me what is capacity planning or how would I don't know, nothing in interview, ask me in the context of manager. So then in a recent cohort, the guy reframed the question and said, what if my manager asked me how to do capacity planning? But I just enforce them to not think from an interview perspective, because then you are stopping at a point where you understand, okay, these are the overall building blocks. But when you go deeper into it, that's where you become the engineer at the next level.
Right.
And it's not saying that I am the engineer at the next level. I'm still learning. I'm still learning every single day. But whatever I've accumulated across this 10 years that I've spent, this is what I've thrown literally everything into this course. Like whatever I had. And just rewiring them and obviously applying first principle thinking. See, it's very easy to build complex systems. Add CDN, add load balancer, add this and that and that and that. You can make it as complex as you want, but simple systems scale. I just make them aware of this fact that it's always, you keep your design simple. If it is not simple, because the third hat that we are the second hat that we are wearing of engineer. Imagine you are the one who are implementing the system. Will you be implementing these many components? No.
Yeah.
Right?
Yeah.
And so when they start to think from that perspective, hey, if I have to implement this part, then they automatically chop down on the extra components that they are adding as complexity.
Yeah.
And a lot of people have a lot of things around like assumptions that, for example, CDN can only serve static data, images. I show them an optimization where I'm serving JSON response through CDN. Like, oh, aisa bhi hota hai. Right? And it's just that there is this gap where people have been attuned to think in a certain way about a certain technology. I just break that, because understand the core property that tool, technology, library provides and see where you can use it. It's not, don't be affixed to a certain tech. See what it is providing and see how you can think out of the box. Because after a certain stage, you have to think out of the box to make that bigger impact. Right? And you have to deal with ambiguity. So I'm just throwing them into real world scenarios. Now think, a lot of brainstorming. Like my session goes for 4 hours also. Straight. Whoever wants to drop off in between, feel free. Everything will be in recording. But I make them think, like go in depth of it.
Right. I think in that Kwesi event, we were also discussing about microservices, for example, right? I mean, while I think one must know how to split up a system into services when the need arises, but then this is not the ABC of programming. You don't start with microservices in the first place. I think in one of the sessions with SCALER pod I had with Dr. Kailash Nath. One of the things I liked is when Nitin shared about he said that the thing about Dr. K is that he always is thinking about the cost of what he is doing.
Yes.
Right. So I believe that's also something you do in the brainstorming sessions, is because there is a cost to everything. Everything is a cost. Yeah. And the cost is also a trade-off. Like maybe, making things simple, maybe there is a cost to that as well. But then making things complex also has a cost to it. And which cost do you want to incur today?
Yeah.
So also, like, what has been your experience in, people who go through this program understanding these things as well, like the cost to it? Is it like something it's very new to people when they encounter this?
Very new. And I was shocked.
Like
that
and also the cost is sometimes dollar, but sometimes also like latency or
Yes.
seconds are cost as well,
Yes.
right?
Yes. So in most cases, when I talk with respect to cost, it's always money, because what I realized is a lot of people have worked in a multinational organization, be it Goldman, Google, Facebook, companies like this, and even in case of startups, they're worked in high skill startups. So there a lot of things go under the ground. Okay, cost ka, it's okay, I'll add this component, that component to do it. But that, if you think from an interview perspective, it would make your diagram look beautiful when you have so many components. But when it comes to real implementation, that's not how you are going to implement it. You try to minimize as many moving parts in your system as possible. Okay? A lot of these people who have that, and they are all brilliant engineers, they are unaware of this part, that they never think cost as one of the axes.
The
They
cost is
don't
also
think
like
about
the
cost at all.
time taken by the engineers to build it is
To
also
build
a
it also.
man-hour cost,
Yeah,
right? And
yeah.
and you can fix a dollar value to it.
Yes,
When you're
true.
leading a team, then there is a dollar value to that cost, right?
True. So this is what, like, I keep on reiterating these things that matter in real world, right? So from an interview perspective, making a diagram look beautiful is what you typically focus at, and obviously answering a bunch of questions around it. But because how much can you judge in, like, let's say 40 minutes of time, right? When it comes to real world, when you are in that situation where someone is asking those critical questions, you need to have an answer on why did you make a certain decision.
Right.
And that first principle thinking of all the axes, that is where I have this like 4 or 5 things that I always reiterate. One of them being this, like, an engineer always have to wear 3 hats, so that they basically consciously remember to wear those 3 hats when they're architecting the system. And that's what would elevate them to become better. Like, I've seen people very early in their career, SD2 to SD3 transition. I've had a couple of staff who became senior staff after the course. Like, I'm still not there at that level, but I've seen people grow. I've seen, like, and that is and basically that is a testimony to the fact that what my thinking approach is, it actually works in real world. So the kind of experience I got in my career has really helped me, and something similar would help others also.
Right.
It's fun, and in most cases I'm intimidated by them. Like, God, these like, I one in one of the cohorts, someone came, my God, who built MapReduce. He was the initial committer in MapReduce. I'm like, God, what would I teach him? Like, okay, one of the person was staff at LinkedIn. I'm like, if I would have known you were staff at LinkedIn, I would have been shivering throughout. And he told me about after 5 weeks over, like after basically first 5 weeks got over, like, okay. But he also found it helpful. So I'm like, okay, chalo, I'm on the right track.
Right.
Yeah.
Speaking about career growth, and actually, like, somebody staff at LinkedIn coming for the program, and they are also still learning in that sense. Actually, want to put forward a question to you, which I get from a lot of people. Sometimes sometimes I laugh at that question myself, and it makes me uncomfortable. But I want to forward that question to you, put you on the spot. And the thing is, I sometimes meet people who are 3-4 years into engineering. And suddenly some mindset starts to seep in, which I have heard from a lot of people. Like, I've been coding for 3-4 years. I know everything about engineering. Now I will have to move towards probably some, management, non-tech role. It could be because they are not seeing the visibility of how much more you can learn, or whatever be the case. Is that something you also encounter when you are interacting with people? And then I would say, on a more philosophical answer is, what is the answer to this? Because I feel like there is so much more to learn, right?
There is. So what I've realized, and to be honest, it's more common than a lot of us think it is, in almost all of my one-on-ones so I do basically one-on-ones with the people who have taken the course, and this is something which is the most common part. Like, should I become a manager or should I continue to be an IC? Like I'm now bored of coding, but I still want to learn, I still want to explore. So one thing, yesterday I got a message from an engineering leader at Amazon, and he said, Arpit, the like, I see your LinkedIn feed, and I want to become an IC again. Like, so what I realized with this is, a lot of people don't know that there is much more to engineering than what they think it is, given the kind of exposure that they would have got in their experience.
Right.
A lot of things depend on that. And if they would have been a little more curious around everything that is happening around them in the product space, in the business space. They would not be in a situation that, and I'm not saying that IC is better. I've basically tested, like I've been on the both sides of the table. Uh, a lot of people who are good engineers, they think that they have seen it all. Problem number one. Second problem, they think it's too boring because they have been doing it for a long time. So it's more about switching the domain. But a lot of people are in their comfort zone, so they don't switch their domain.
Yeah, I think the
That is a
challenge
big
not
problem.
coming is a big problem. Then you
Yeah.
realize that maybe I am at the ceiling somewhere.
Yeah. So they think that itna hi hota hai, and that's not true. And thinking of going out of the comfort zone is very important. Like if I would have just stayed in my first company where I was writing web scrapers, after 6 years I would have said, I know everything. Like I'm in my comfort zone, I'm doing it. But then it would not have made me a better engineer, right? Then I explored DevOps. Then if I would have said, no, this is all I knew, right? I cannot stop at that point. Then I moved to data pipelines. Then I moved to search. Then I moved gamification engine. Then to people management, right? Putting yourself in uncomfortable position is really important so that you know what you don't know.
Yeah.
And which is where a lot of engineers think that they are done with their thing and now I want to switch to management because then I can grow horizontally and move and lead different teams and all. They think it is abstracted out. It is not. Manager also needs specialized skills in the domain. When you work in a challenging environment, you would realize how important domain expertise are even for a manager. And with engineers in basically today's day and age where they think that like obviously they think the world is very fast moving. They think in 5 years they know everything.
Yeah.
Right? And it's that lack of curiosity. It's that, and obviously it's maybe because of lack of motivation due to other commitments that they might have, but more about basically consuming the right type of content, being with the right set of people, following right people on social platforms would have altered their mentality. But if I think about it more deeply, and I have in the past, it all starts at a grassroots level where we are not taught to be curious.
Our education system does miss out on
Yeah.
that a lot. It's like,
If
padho exam do.
Padho exam, correct, right? So if you are curious around the things that if you are extremely, like I say that I am innately curious. I was never a good student till 10th. After that, my mindset changed totally because I stopped going to tuitions. My parents gave up on me that he would do nothing. And literally, my father bought me 2 or 3 books. If you'd want to read. If you crack exam, it's okay. Otherwise, we have a business. You can drive that. And I explored those books. Those were all out of the syllabus books. But I explored and I learned because I wanted to. And from 10th onwards, my mindset changed around being curious. Triple IT, it went to the next level because I saw all of these PhD holders around me. I'm like, God, these guys know stuff. And I'm like, okay, I want to go deeper and explore. And that curiosity part is what I bring in. So a lot of people who take my program, they always say this, that like, you have made me curious again about computer science. Because they don't know what they don't know. They just take it for granted. They just think that using something as a black box is what it is. No, it is not. Someone is building that part. Right? Be extremely curious. Like even when I joined, even when I came here, I was going in the backstage seeing what these people are doing. Like, and that made me curious. Like, how does lightings work? How are they removing the glare and whatnot?
Yeah.
And that curiosity, that asking questions, like ability to ask questions, or rather having an intent to ask question is the most important part. And a lot of engineers miss out on that, unfortunately. And then they think that managers don't do anything. So let me become manager and live a happy life. But if you are a curious engineer, like go for it. Engineering is the best. And obviously do switch on the other side to understand the outcome part of it rather than only the output part of it.
Yeah, that's funny because you just mentioned about the studio setup and everything. That's something. It's very common across a lot of the guests who have come also earlier. They'll be like, "Kya do you do color grading afterwards, or do you do in what format is it recorded?" People get very curious about the technical details. It's a very common theme. Right. And towards the end, one final question that I always ask people, because I want to know all of these answers, to looking towards the future, right? And these days, I see obviously a lot of upcoming things, a lot of places like GitHub Copilot, ChatGPT, AI-based code generation. That's one space. Low-level languages also, Zig, Carbon. These things are coming up. So there's lots of new things happening. From your vantage point, all the new things in technology that are coming that you're seeing, what are 2-3 things that you are very excited about and you want to see them grow or want to see how it turns out?
One thing I'm really excited about is augmented reality.
Okay.
Because that is the closest to be actually be real. Because if you think about VR takes you in a different zone. There is still a lot of gap. There is still a requirement to have a product market fit. Augmented reality has a ton of use cases, which I feel is the closest which is actually the closest to a breakthrough, right? And we would see it. We would see basically ARs in next 10 years, at least, like at max 10 years, right? We would see ARs being
There
very
are some
common.
cities outside India where that Google Map AR thing works.
AR
And I
thing
really like it because sometimes because you're a little indoors or something, it won't be able to show where are you. Then you put up your camera and then it shows us, okay, you take the right turn from there.
And that's really cool. AR is something that I'm really fascinated by, more than VR space. With code generation, or rather with basically, let's say, Code Whisperer, or let's say ChatGPT and all. So these are what I feel will be an aid to a developer or an engineer to basically get subjective answers. You may not rely on the entire correctness of it because you don't know what the model has been trained on. Obviously, a lot of work would go on. Like yesterday only, I saw someone asking ChatGPT that what are the last 8 digits of pi, and it answered. Then that's not possible, right? So basically, whatever the data set that it was given, it had pi up until that particular stage. So it said, okay, these are the last 8 digits of pi, right? And this clearly shows a gap. This clearly shows, like, basically what you feed is what you get out of it.
It's a smart man's tool, not a dumb man's tool in that sense.
Yeah,
like
exactly.
If you can find out the answer is correct or not, then it is useful. But if you don't know whether the answer is correct or not, then just trust it.
Yeah, you can't just trust it. And obviously, people would argue that it would take time for them to learn and build out those data models. But still, you cannot just think, oh, this particular GitHub Copilot would replace me. It would make life simple. So companies might need fewer developers, but good engineers is what every company would always need, because they just cannot rely on an AI to ship things to production.
Yeah. But it does help in the sense I have been using Copilot. So sometimes, like, I start writing a function and then it generates 50 lines. While the entirety is not correct, but just editing 2-3 lines, you finally get the actual answer. So the thing is that it saves me writing 50 lines. But then if I did not know what I was going to write, like in my mind, the function is already made. Then I am going to write. As soon as I write, ChatGPT Copilot suggests it. But then I see, the if condition, they have made the opposite one. Now the thing is that in an AI model, in a transformer model, it's more like pattern matching, right? So if they could generate an if condition, and if not true or if false kind of a thing, it's very easy for the model to flip it because they don't know what is the point of true or what is the point of false. They're just pattern matching and similar text they're generating. So you have to revisit and fix it. But then it does save a lot of time. It sort of gives you
It's a good aid. So people would use it a lot in the coming future, but it is not going to like replace everyone. It would definitely be chopping down on some cost. That's why, like, keep learning, keep growing, be curious is what, like, you should always, like, just become a better engineer.
And then I think I saw, I think we interacted on Twitter about that Carbon language that has come out. So what are your thoughts on? I think there's a lot of advancement that's happening on low-level programming, which for a long time was stagnant. Like there was C, then there was Go, but people are trying to do everything with Go. But I think now there are some advancements there.
A lot of language. So now what has happened is, again, given that hardware has gone through a tactical shift, because 10 years ago, SSDs were like not mainstream. Now SSDs are. So similar to how database is going through the transition, that now more and more people want to leverage SSDs and the way its read and write model work. Same thing is happening with programming languages also. Because operating systems have also evolved. Right? Now you see Rust getting adopted almost everywhere. Right? You see Zig, you see Carbon getting adopted. Right? And obviously it's still basically very nascent in its stage. But people are experimenting with it because now because now we have this hardware capability of leveraging and making it optimized. Like the way Go is structured in its internals is how it has put this basically variable name at first and then type later. It improvises the way, or rather it makes parsing more efficient.
Yeah.
Right? Now all of those nitty-gritties, all of those minute details, they matter. The way Carbon is reimagining C++ is also interesting because now it's now very much clubbed with the underlying hardware. Now the next level of optimizations are coming in because now hardware had enough time, or the overall CPU processors, they had enough time to evolve new set of instructions that the low level languages like C, C++, or rather in that matter Carbon can leverage. Right. Now, given that there has been enough time passed, now these folks can build on top of it. And which is where you see Rust adopting this almost, if I may put it, brand new way of doing garbage collection, that you don't need garbage collection at all, but it will still work. And that's really neat. Right. Now, and these are not new. And if we look carefully, a lot of people think, hey, these are breakthrough. Like, why did no one think about it? The paper about it was published 20-25 years back.
Yes.
Computer scientists back in 1980s, 1990s, they did a lot of heavy lifting. The approximate algorithms that I was talking about, which makes New Relic or Datadog possible, they were designed 18 years, or rather, they were designed 20 to 23 years back.
Yeah.
Now, the world is literally revisiting them because those folks did some amazing because they had those memory constraints. They had those hardware constraints.
Yeah.
And now people are leveraging those learnings into making existing things better. So we are literally revisiting the old literature. And I'm not even kidding. The last 10 papers that I read were all from 1990 to 1996. Because that's where the wealth of information was. Because they did a bunch of we are just using it and we're like, oh my God, this is so new. Like Redis does approximate counting. The algorithm it uses it came out, the name is the Morris counter. It came out in 1990 something.
Right.
It's that old. So that is what people say, like the overall CS fundamentals, they are everlasting. This is a prime example of that. Right? And all of these compiler optimizations that are happening, I just went through Go source code a bit, some of Carbon, just to see what they are doing new, like basically very superficial understanding. But a few optimizations that I spot were like that, which I read in a few papers already.
Yeah.
And this is when I realized, this is how the world is actually moving back to the basics and re-optimizing the things that they did again.
I had a similar experience when, I'll probably have to develop more habits of actually reading research papers. Like I'm getting inspired sitting right now. But one of such things happened when first time Kotlin came out and Android development was moving towards it. Like even before Google announced it and all, like people who were enthusiasts in the community started saying that, hey, this is a nice language and most likely we'll move towards it. Because Swift had come out and people were like, hey, the transition from Objective-C to Swift, everybody is Java developers, Android world, like we should use a language like that. And then like it had the very experimental form of coroutines inside it that time. Now it's very common, like you do coroutines only, you don't do directly threads. But then there was this I think a document called Keep. So they have this Kotlin, I think there's a RFC kind of thing, they correct Keeps. So I'm forgetting the name of this guy who was the architect at Kotlin at JetBrains. He has created ICPC papers and all as well. So anyway, so he had written about the state machine thing, right? So that was the first time I was coming across the concept that, you can do compiler optimizations with state machines and make basically concurrency embedded into the compiler technically. So when I was reading, then I went like double back on that and found, okay, there were research papers in 1950s, 60s written, which talks about in a very theoretical world in terms of computers where state machines can let, this multiplexing of two different time slicing functions and all. And but now at an application layer, all of these things are happening a lot. For example, React has time slicing now. When coroutines are happening, all of these things are basically implementing fundamentally the same thing.
It's exactly like physics, like how a theoretical physicist lives, let's say 50 years in the future, experimental physics takes time to catch up.
Yes.
Right? It's exactly like that. Like a lot of great computer engineers back then, they did a lot of, they laid a lot of solid foundations.
Yeah, but they wrote it mathematically. Now we are able to implement it today. Right. Also interesting. I think the thoughts on the future are really helpful. And, thank you for all the answers. Few of them have been really inspiring for me as well. I'll go back and start reading some research papers from now because there have been instances where, finding out something led me to a research paper and gave me a lot of learning. But like this kind of a thing, having quarterly goals is something I'll probably try. But once again, thanks for taking out the time and
Thanks so
sharing.
much for having me. It was really fun chat. Thanks.